Good day to everyone. I am Darren James C. Goling, and I'm also here with my colleague.
Jimber Lemuel B. Garcia.
And we are here to proudly present our research that is entitled Development of a Non-Contact Cough Recognition System with Face Mask Detection and Distance Assistance using Convolutional Neural Network. And our advisor here is Dr. Jennifer C. De La Cruz. So without further ado, we're going to start our presentation.
So, in this research, we developed a non-contact cough recognition system with face mask detection and distance assistance using CNN. For our first objective, we acquire a cough signal data using a REST speaker for microphone array with MFCC and audio localization. Next, our second objective uses a high-definition camera with CNN model to detect face mask from an individual facial image. Third will be similar to the second objective, but we integrate a social distancing detection to provide a distance assistance. And lastly, we determine the accuracy of the system for cough, face mask, and distance detection. So for our scope and limitation, this study simulates an area that will monitor complies to the proper health protocols and detect coughing as one of the signs of the illness through a camera which adopt the function of a CCTV. In addition, it will only monitor individuals who are coughing, wearing face masks or not, and practicing social distancing. Every violation that will occur under the condition of the recognition system, it will prompt green and the red indication which define the notification to alert the authorities or the user. The implementation of the research will be in a controlled environment to have a better accuracy, and the prototype is placed together in a one working device. But in the case when the sensitivity of the microphone is insufficient, the microphone may be separated from the recognition system. So the output of the system was only based on the specification of each component that was used. And lastly, the system will work under optimal operating conditions.
Now we move on to the methodology part wherein we've come out with an output after the cough signal output happens. Now for the cough signal analysis, we use the MFCC to filter out cough signal from other audio signal wherein MFCC stands for mel frequency spectrum coefficients. So on the third picture shown here is the pre-processed audio spectrogram magnitude. Another feature would be the extracted features are preserved the information regarding the beginning and end of the cough event to be inputted into the CNN. Table 1 shows the cough signal spectrogram produced by the subject with varying distances from 0.5 meters to 3.0 meters away from the microphone array. Having these parameters will determine the consistency of the recognition system, detecting different intensity in set of distance. After calibration of the optimal location and distance of the recognition system, cough mapping is the next procedure. The main function of the cough mapping is to identify whether a subject is coughing or not with regard to cough audio signal. In addition, the recognition system will have a controlled environment in order to neglect some background noise produced by other sources. After that, we integrate the cough mapping in an image, so we get different types of video wherein a person is trying to cough or in an act of coughing. So we can see here on the picture below wherein uh, the first picture is the image of a cough that may happen. Then on the next image would be the cough. So we're going to dig deep on how the audio location starts using the CNN. So first is that the model that is presented in the figure from the cough filtering method or the cough signal analysis on the first part, you can see the input audio visual pair is where the cough mapping and the detection is located, while on the lower side, which is on the downmost part, it is the input of the spectrogram. So on the second page of the audio localization, the input spectrogram is always running with the system. So we use this type of approach because the system get more bugs and makes the accuracy lower for other detection system such as the face mask and social distancing. So here is the audio localization or the after product. When the microphone detects a cough audio signal, an image of the location would pop up. Then next would be the image of the person that is on an act of coughing. Then lastly, the overlapping of the picture of where the cough signal came from and where the person that is in an act of coughing.
So moving forward, for face mask detection system, training a data set plays a big role in accuracy, since the more the dataset one program has, the more accurate the detection is. In this research, we gather a large number of datasets from different sources in the internet, such as GitHub, Kaggle, and etc. In the case that we need more implementation of dataset, training a data can be another way to have more dataset. This is usually done by collecting different facial image of a human, and then the program will, with an algorithm to train and put face masks in different facial image. And in addition to that, wearing different head accessories are other factors needed to be considered. So for the physical distance detection, this is another term for social distancing detection. In this research, we use a binary classifier, MobileNet V2, since it reduced the form of mobile semantic segmentation models that is new mobile architecture that utilize neural network to filter the input of the
So
program.
using
Using
the
the binary
binary
model NetB2 is to differentiate a human form from another object, and then applying distance from the object, it measures the depth of the field from the camera to the object, and then again implementing the distance but more focused on detecting object from one subject to another. This research uses a confusion matrix as a way to compute the accuracy of our program. The table presented consists of two categories, which are predicted and actual values. And combining the two categories, we resort to four outputs, which are true positive, true negative, false positive, false negative. The output of the accuracy will determine how effective our detection is. In addition, the output should be as high as possible, since the goal of this recognition system is to detect every subject passed through the vision of the device. So on the right side of the screen, you can see the accuracy, the positioning of the height between the recognition system and the subject that were used in this research were 2.5 meters. This is since this is the minimum standard wall height that most of the building in the Philippines has. So for the table 3 and table 2, it determines what specific distance does the system is optimal. In addition to that, in every distance, the system detects two or more subjects, since this is the part where accuracy is not only important but also the precision and consistency of detecting both wearing and not wearing face masks, and the accuracy that can be obtained by the multiple numbers of subjects with varying distance from this subject. Based from the findings, face mask and distance detection show that the best possible distance is to detect the detection from ranging 1 meters to 1.5 meter, 1.5 meters.
So we've moved on to the results and the discussion. Wherein on the first part we have the cough detection part, wherein cough sound mapping has garnered an accuracy with corresponding with the said formula of the confusion matrix, wherein the accuracy is around 82%. For the next part would be the multiple coughs recorded, wherein we've garnered a 76.67% accuracy. In relation to other research conducted by Kadami and Yangtze, they used a lapel microphone to detect audio-based assessment cough. In addition, this research implements a wearable cough detector with accuracy of 97.67% and 98.2%. And relating it to our research, it is proposed that it is a non-contact cough recognition model wherein it detects cough mapping in order to examine the actual footage of a person that is coughing. So in table 4, this shows the 50 trials of the cough mapping detection, wherein it garnered an 82%. And for table 5, the multiple cough detections, wherein actual number of coughs are being recorded here.
For the face mask detection as well as distance detection, we believe that having a table with a different number of subjects can determine how accurate the detection is. Thus, we added more table varying from one subject, two subject, and three subject for both face mask and distance detection. So for table 6, it shows that there will be one subject that is wearing a face mask in users and system perspective. In the result, the highest value was the true negative with a value of 21, followed by true positive that has a value of 5, and the false negative that has 4. Having this, we can compute the accuracy using the formula of the confusion matrix, which is presented on the left side of the screen, resulting to 86.67% for face mask detection under one subject in vision. So moving forward, so for the table 7, now there will be a two subject that is being detected by the system, value of 8 giving us the accuracy of 63.33% in detection of two subject under face mask detection. So the last table will show detecting three subjects at the same time. The true positive and the true negative has a value of 9 and 7 respectively, while the false negative has the highest value of 14. Therefore, the accuracy of the detection of the face mask with a tree subject falls under 53.33%. So, moving forward to the distance detection has the same implementation as the face mask detection, just like I said earlier, that both of them will having a different table with a varying subject to be detected. In this table 9, the distance detection with one subject has the highest accuracy with a value of 80%. So for the next slide, now we are looking on detecting two subjects on distance detection, giving us the accuracy of 73.33%. So for the last table shows three subjects on vision with the same accuracy as the previous detection, which is 73.33%. So to sum up, the accuracy of the recognition system is far from the accuracy given by the technique by Zheng Xiaoshu from the object detection in 20 years research, since they use a deep learning technique to be more specific face mask net that determines whether a person has a face mask or not. While from this research, we believe that binary classifier mobile net V2 is suited for our research. In addition to that, the findings where more subject is present on the area, the lesser the accuracy is, since our priority was both face mask and distance detection will work simultaneously.
To conclude the research, the system was able to detect and map the location of the cough sound signal with a 82% and 76.6% accuracy for cough signal mapping detection.
So for the face mask detection, we were able to get an 86.67% for one subject, 63.33% for two subjects, and 73.33% for the three subjects. For the next detection, which is distance assistance, garnered a 80% for one subject and 73.33% for both two and three subject in terms of distance of one person to another.
Lastly, the overall system was working in terms of functionality and were able to detect each of the objectives as soon as the model recognizes it.
So for our recommendation, first is to have a larger and higher quality sample size of dataset for all the detection mentioned in this research, and in training it, it will lead to have a better or higher accuracy rate.
Next, the ways to increase the accuracy of the mapping is to widen the audio dataset to gather other types of sounds such as clap sound, phone drop, and other types of sound. Next would be improve the mapping of two or more people having simultaneously coughing together. In order to improve the cough detection and mapping, the use of much higher end or specification of microphone is recommended. We believe that the use of beamforming microphone is much better, but it would be more expensive.
So lastly, we recommend to use a higher specification of microcontroller such as Jetson from NVIDIA and Ryzen microcontroller from AMD, or Raspberry Pi with a higher GPU and processing unit, but it will cost higher compared to the materials that were used in this research. Having this upgrade will serve to decrease the time needed to process the GUI, and at the same time giving a better accuracy since it is capable of running programs simultaneously, as well as more strong processing unit, resulting to well proper detection for the subject. So this is our research entitled Development of a Non-Contact Cough Recognition System with Face Mask Detection and Distance Assistant using Convolutional Neural Network. Thank you for listening